Okay, so let's talk about section 1.6. In section 1.6, we're going to be learning how about other types of equations and applications. So first let's start with what are called rational equations. And remember what rational means. Rational just means it could be written as a fraction, like 1/2. But if it's a rational equation, that means there's going to be a variable in the denominator. One thing that comes up with rational equations is it's possible to get what's called an extraneous solution. And what an extraneous solution means is this is an answer that just doesn't work. So you did all the math right, but it's just not going to work. And with rational equations, what could happen is you could get the denominator equal to 0. And obviously that's not allowed. This could also happen with absolute value, where you do all the math right, but just based on the definition of absolute value, you can get an absolute value of a number is equal to like -2 or something. Absolute value is always going to give you a positive answer, so that's why this wouldn't make sense. And another thing that could happen is if we have radicals. If you ever get a radical where you're taking the square root of a negative, that's going to be a problem. You know that that'll give us an imaginary answer. But also, if we have something like the square root of a number is equal to a negative answer, that's not okay either. Whenever we take the square root, we always get 0 or a positive number. So those are different types of what are called extraneous solutions. Let's solve some rational equations. We just want to make sure that the denominator isn't equal to 0. So let's start with x over x minus 2 is equal to 2 over x minus 2 plus 2. Now there's a few different ways we could solve this. One thing that we could do is we could bring this fraction over. Actually, I'll show you a few different ways. So we could bring this fraction on this side. So we're going to have x over x minus 2 minus 2 over x minus 2 is equal to 2. So we can combine the fractions. X minus 2 over x minus 2 is equal to 2. And let me just see here. Yes, we could make this where we could write this 2 over 1. But really, these are going to cancel, and we're just going to get 1 is equal to 2. So there's actually no solution for this. Let's see if we get the same answer doing another way. The other way I was talking about, this way we'll just call it common denominator. Second way, this is the way that I would prefer, and I think most of my students would too, is you multiply everything by what's called the least common denominator. In this case, the only denominator is x minus 2. So we're going to multiply every term by x minus 2. So let's see what happens. X times, let's see here, x minus 2 times x over x minus 2 is equal to x minus 2 times 2 over x minus 2 plus x minus 2 times 2. These cancel, we just get x. These cancel, we just get 2. And then this is going to be 2x minus 4 So if we get the x's on the same side, we get negative x is equal to negative 2. X is equal to 2. Well, that's not the same answer we got before, but actually the answer is no solution, because if we were to plug in x equals 2, we would see that the denominator would equal 0. So whenever you get an answer, if it's absolute value, radicals, or rational equations, you just want to double check. You can't say that an answer is an answer unless it works for the whole problem, right? So because 2 makes the denominator 0, that's not included in our answer. Let's try something else. We'll number this letter B. And let's try 3x plus 2 over x minus 2 plus 1 over x is equal to negative 2 over x squared minus 2x. You could try to get a common denominator and combine fractions, but generally what I always recommend is just get rid of fractions. I think most people have the most success doing it that way. You could get a common denominator, there's nothing wrong with that, but from my experience, most people prefer to just multiply by the least common denominator. In order to figure out what the least common denominator is, we have to make sure that all the denominators are factored. And now we could easily see we definitely need a factor of x minus 2, but we also need a factor of x. So we're going to multiply each of these fractions by the least common denominator to get rid of all the fractions. So x times x minus 2 times 3x plus 2 over x minus 2 plus x times x minus 2 times 1 over x is equal to x times x minus 2 times negative 2 over x times x minus 2. So it looks like these are going to cancel, and we'll just have x times 3x plus 2 plus these x's cancel. We're just going to get 1 times x minus 2, and then this whole denominator is going to cancel, is equal to negative 2. So let's finish this problem as I get a drink. All right. So let's go ahead and finish this. We get 3x squared plus 2x plus x minus 2 is equal to negative 2. So we get 3x squared, combine our like terms, plus 3x, and then if we had 2 on both sides, that would actually just cancel. So remember how we solve. We have all our different tools. We want to try to, if it's simple, we could just solve it, but most of the time we're going to have to factor. If that doesn't work, we could use completing the square. We could use quadratic formula. In this case, we could just take out a 3x, and we're left with x plus 1. So using the 0 factor property, we set these factors equal to 0. And we get x is 0 and x is negative 1. Let's go back and check just to make sure that x could be 0 and x could be negative 1. Well, it definitely can't be 0 because that would mess up that fraction right there. So that's not an answer. That's extraneous. And negative 1 looks like it's okay. So it looks like the only answer here would be negative 1. Next, let's move to radical equations. We want to make sure we check these for extraneous solutions too. So for example, what if we had a problem like this? Square root of x plus 3 plus 5 is equal to 2. Okay, well, let's isolate the radical. That's the way we do most of these problems. We isolate the radical, square both sides. If there's more than one radical, we're going to isolate the more complicated radical, square both sides, and just keep doing that process over and over again. So let me just write those steps down. Isolate the most complex radical, and then square both sides. And if there's more than one radical, we might have to do this process over again. So we isolated the radical. Let's square both sides. We get x plus 3 is equal to 9. X is equal to 6. Well, the problem is if you caught on right here, we have a square root is equal to negative 3. That'll never happen, so I know that this is extraneous. No solution, because it's extraneous. But if you didn't catch it, just go back and plug 6 in. Let's see if it works. If that's an answer, the left side should equal the right. 6 plus 3 is 9. The square root of 9 is 3. So this is 3 plus 5. That's not equal to 2, so 6 would not work. There's no solution for this. Let's move on to one a little bit more interesting. How about x minus the square root of 15 minus 2x is equal to 0? Well, according to our steps, let's isolate the radical. I'm just going to bring this over. We'll square both sides. We get x squared is equal to 15 minus 2x. Let's get everything equal to 0. That's how we solve quadratic equations. And I think we could factor this. Just doing a little bit of a shortcut now that we've practiced factoring. One thing we could do is, we know that these first two numbers have to multiply to be x squared. These last two numbers have to multiply to be negative 15. But when you add these two plus these two, you have to get 2x. Or you could just do it the long way that we talked about. You should know how to factor trinomials. So they're going to factor to be x plus 5 and x minus 3. So we get as our answer is x plus 5 equals 0. X would be negative 5, and x minus 3 is equal to 0, so x is 3. Okay, so let's go back and just make sure that both of these are going to work out. If you plug in negative 5, we get negative 5 minus the square root of 15 plus 10 is equal to 0. So is negative 5 minus 5 0? No, so that's not going to work. Let's try 3. 3 minus the square root of 15 minus 6. Does that equal 0? Yeah, so it looks like that's our only answer. All right, let's try one more. And we'll move on to some other types of problems. Let's say we have the square root of 2x plus 3 minus the square root of x plus 1 is equal to 1. So let's isolate the harder radical. I think this is it, so I'll bring this to the other side by adding it over. And according to our steps, once we have the harder radical by itself, we square both sides. Now, please don't do this. We said you cannot distribute exponents over addition or subtraction. So what we have to do is we're going to have to FOIL that. On the left side, squaring a square root just cancels. But on the right side, we are going to have to do 1 plus the square root of x plus 1 times 1 plus the square root of x plus 1. And we get 2x plus 3 is equal to 1 plus the square root of x plus 1 plus 1 times the square root of x plus 1 plus, well, look at this. We have a square root times itself, or the square root of x plus 1 squared. So let's see what we get. We get 2x plus 3 is equal to 1 plus, well, we have two of the same radicals, and then plus x plus 1. Okay, so remember what we said for our steps. We said isolate the most complicated radical, square both sides, but then I drew that arrow. So we still have a radical hanging out here. So let's try to isolate that, square both sides, and hopefully that'll take us home. We could subtract x on both sides. 1 plus 1 is 2, so we could subtract 2 on both sides. And let's see what we get. We get x plus 1 is equal to 2 square root of x plus 1. Just make sure I did that right. These x's cancel. That would be x. Plus 1 is 2. Yep. So now let's get that radical by itself. And we get x plus 1 over 2 is equal to the square root of x plus 1. Now it is by itself, so we could square both sides. And let's see what that turns into. X plus 1 times x plus 1 over 4 is equal to x plus 1. Can multiply both sides by 4 to get rid of the fraction. And if we FOIL out the top or distribute it, we get x squared plus x plus x plus 1 is equal to 4x plus 4. And now we're in the home stretch. X squared, this would be 2x minus the 4x, and then subtract 4 would give us minus 3 equals 0. Using the 0 factor property, this would be x minus 3 and x plus 1. I know that because x times x is x squared, so that gives us this. Negative 3 times 1 is negative 3, and negative 3x plus 1x is negative 2. So we'd get x minus 3 is 0, x would be 3. X plus 1 is 0, so x is negative 1. All right. Let's go back to our original equation and just make sure everything works. If we plug in 3 and negative 1, does that work? So if x is 3 and x was negative 1, I think I said. Yep, let's just double check them. If we were to plug in 3, we get 6 plus 3 is 9, so that would be 3 minus 2 is 1. So that definitely works. Let's try negative 1. We get the square root of 1 minus 0 is equal to 1. That definitely works too. So both of our answers are fine here. Okay, and now what we're going to do is finish up using rational exponents and quadratic techniques. Well, let's take a look. How about x minus 4 to the 2/3 power is equal to 16. So that's a rational exponent. It means the cubed root of x minus 4 to the 2nd power. But I'd really like to get rid of this power here. That looks kind of complicated. So think about our power to a power property. If I raise both sides to any power I want, what can I do to neutralize that 2/3 or make it into 1? So 2/3, power to a power you multiply. 2/3 times what number is 1? It's reciprocal. So if I raise both sides to the 3/2 power, when you multiply it just cancels and you just get x minus 4 is equal to 16 to the 3/2, or the square root of 16 to the 3rd. You can see how well the properties come into play here. Square root of 16 is 4. 4 to the 3rd is 64. So our answer here would be 68. You could check your answer if you plug in 68. 68 minus 4 is 64. The cubed root of that is 4. 4 squared is 16. So that works. How about something like this? This is a little bit different. If it was 6x to the negative 2nd plus x to the negative 1st is equal to 2. Well, whenever we're solving equations that look like they're kind of complicated, we try to make them equal to 0. And that's a trinomial, but I'm going to show you a little trick. We could use something called quadratic techniques for this problem. Now what quadratic techniques means is we can make a substitution. Like let's write this 6 times something to the second plus something to the first minus 2 is equal to 0. That's what a typical quadratic problem looks like. If we put x to the negative first here, is that the same thing? Negative 1 times 1 is still this. Negative 1 times 2 is still this. But what we could do, it's always going to be this middle term that we make a substitution for. So instead of using x to the negative first here, let's just make up a variable and call that y. So we get 6y squared plus y to the first minus 2 is equal to 0. Well, that's pretty easy. That's something we could do. Let's go ahead and factor this. It's a little more advanced, so I'll use the AC method. 6 times negative 2 is negative 12, but they have to add up to be 1, so 4 and negative 3 would do that. So let's go ahead and factor this. 6y squared plus 4y minus 3y minus 2 is equal to 0. Cutting it down the middle, we could take out a 2y. Take out a negative 1. You can see we factored correctly because we got the same thing. And we get y is equal to negative, shouldn't skip steps here. We can make this equal to 0, bring the 2 over, and then divide by 3. Y is negative 2/3. We're going to do the same thing over here. 2y minus 1 is equal to 0. So 2y is equal to 1. Y would be 1/2. Now don't get too excited because we solved for y, right? But remember, y was x to the negative first. So let's just make that substitution back. And just like before, if we want to get rid of that power, we could raise both sides to the reciprocal. And anytime we just have a negative exponent, that tells us to actually take the reciprocal, right? So this would just turn an x to the first. And negative 2/3 to the negative first, we'll just spin the top and bottom, right? This would be 2 to the negative first, 3 to the negative first, just switch the position. Negative 2/3 to the negative first would just be 3 over negative 2. Same thing with this. This would just be x. 1/2 to the negative first, just switch the position, take the reciprocal. 2 over 1 is just 2. We're actually going to use that technique for our last couple of problems here. I think that was letter B. So we have 2 more to go here. Letter C is 12x to the 4th minus 11x squared plus 2 is equal to 0. Well, if we can make this 12 times something to the second minus 11 times something to the first plus 2 equals 0, then we could just solve it like a normal quadratic. Now remember what I told you, this is always going to be what we substitute. That's how it works. X squared to the second is 4. 2 times 1 is 2, right? So that works. Let's make that substitution, and we'll let x squared be y. Going to have to use the AC technique because these numbers are getting kind of big here. 12 times 2 is 24, negative 11, factors of 24, that add up to 11. All right, so we have 2 and 12, it's not going to work. 3 and 8, okay? If both of them are negative, they would multiply to be 24 and add up to be negative 11. So let's go ahead and factor by grouping. Cut it down the middle. Take out our GCF. And then set these equal to 0. But don't get too excited because y is a made-up variable. we substituted in x squared, right? So let's put that back where it's supposed to be. If x squared is equal to 1/4, when you go to take the square root of a fraction, it's the square root of the top and bottom. We're not going to forget anytime we take the square root of a quadratic, that's absolute value. So we get x is equal to plus or minus 1/2, two answers because it was x to the second. And x squared is equal to 2/3. When we take the square root here, get absolute value. We have to rationalize this. Not a big deal. And we get x would equal square root of 6 over the square root of 9, or 3. It's a plus or minus. Okay. And then for our last problem, it says x plus 1 to the 2/3 power minus x plus 1 to the 1/3 power minus 2 is equal to 0. Well, that looks really hard. But what if I can make this substitution? What if I could just say y is equal to x plus 1 to the 1/3 power? Would that work? I'm just going to substitute that in, right? So I'll put x plus 1 to the 1/3. 1/3 times 2 is 2/3, so that works here. I'm going to put the same thing here. 1/3 times 1 is the same thing. So yes, we could totally make that substitution just like the other problems. So I'm going to put y instead. This one's pretty easy to factor. You need a y and a y. The last numbers have to multiply to be 2, but they have to add up to be -1. So this would have to be -2y, and this would have to be +1y. Using the zero power property, y plus 1 is equal to 0. Y would be -1. Y minus 2 is 0, so y is equal to 2. And then we could substitute x plus 1 to the 1/3 is equal to -1, just putting this back here. And if we want to get rid of the 1/3, like we saw before, we could just raise both sides to the reciprocal power. Because if we multiply 1/3 by its reciprocal, it'll just turn into 1. Reciprocal of 1/3 is 3 over 1. So this would just be x plus 1 is equal to -1 to the third. X would equal -2. X plus 1, these would cancel, would equal 8. X would equal 7. All right, stay tuned for the next lesson.